Hi, I'm Scott Campbell with Solve 3D.
And I'm Brad Ashley. Welcome to video 2. In this video, we'll be going through the labeling of your data using those orthomosaics.
Yeah, there's a number of really important things to think about as people start to get ready to train their model. Brad, so maybe we should cover off what those important things are.
Some of the important items are thinking about what type of data you're using. In this case, we're going to be using an orthomosaic that was collected. Think about the resolution, think about the size, all those sorts of things. And then as well, think about whether the actual piece of the data that you're using for training has enough examples of the item of interest. We're going to show you some examples of what could work and what won't work based on our experience. Also, you want to think about how many classes you want to label at one time. If you're interested specifically in cars, are you going to create a model specifically for that? Or do you want to do cars, parking, markers, etc., all in one model? And then the last piece that's important to think about is the whether the data is too large and for what you're trying to label.
Okay, Kevin, let's get into step one, which is labeling of the training data. Take us through how you go about loading up the data and then labeling it before you do the training of the model.
Sure. So let's take a quick look at the workshop data here. We have a few folders. We're going to be concentrating on the training data folder here and the labels. And you can always look at our results later if you want to see these, but we're going to be using the training data and the training labels to create a model inside the My Results folder and train up run the detection on our image and see what the kind of results that we get. So first, we're going to add our image tile or orthomosaic to the solved engine viewer. We're just going to click and drag it. That's one way of adding it. Alternatively, you can always click add item and add an orthomosaic and select it that way. So I've added it here. You notice it's probably in the wrong place in the world. We haven't defined any projection yet, so we need to change the projection. So we go to edit, the top left here, and we click, I know this is in the UTM-12 projection, so we select our projection here under data projection, hit update project. If your projection is not in this list, you can always go to tools, projection manager, and you can add it into this list here, and then it'll appear in the under the pencil here. So now that we've defined it, you can see now that it's in the correct place in the world. So we're going to concentrate on this little bit area here. So to open the aerial classification setting, you go to Tools, Aerial Classification, and a little window pops up. So the first things you weren't going to want to do, say we're interested in try to find all of these cars and maybe these handicaps paint markings. We're going to start by defining a training area that we're interested in. So this image is, if I zoom out, this image is rather large. There's cars all over the place. We don't want to go through and label all of these. That's what we'll let the machine learning do. So we're going to just concentrate on this one parking lot to give it some examples for training. So I'm going to click the enable training button, and it's popped open a training areas thing here. You can define as many training areas as you want, but I'm going to add a new one by clicking add new training area. I'm going to now draw kind of weird looking box around this parking lot. Maybe I'll just go right here. And this is going to tell the algorithm that only look in this area for examples of cars. So now I'm going to click add class and give it a new class name, cars. And I'm going to add a second class called handicap. So we'll look at cars first. So to define a label around a car, you just click this plus button, add new label. And then you can zoom in here with your mouse wheel, and you start by drawing little boxes around each car. You can always hit the space bar.
I noticed when you drew that label, you're leaving a little bit around the edge of the vehicle. I'm assuming that's intentional.
It can be. It really depends on the object you're trying to find. The algorithm does like to learn off some context around the object that you're defining. So, if you have a vehicle on some grassy surface or on a pavement, it will learn those differences and be able to identify both. If you're doing things like maybe building footprints and you want to, define an exact boundary around that building, you might want to be a little more closer to that building and be a little more exact. So for the purposes of cars, it doesn't really matter.
So, like many things in machine learning, deep learning is the answer is it depends.
That's right. Yeah. So I'll just do a couple here and then I can import a file that I've done later, but let's just show you the handicap ones. We're going to scroll down here, click add plus for the handicap and start clicking a little square around those guys too.
Now, I see you've got little handles on these labels. I'm assuming that when I go to check my work, I can adjust the label. I can
That's
make it
right.
bigger or smaller.
You can always right click on any of these and go edit label or delete it if you want to start over again. Edit label will just let you insert a vertex in here and then you can start by hovering over on it and dragging it wherever you need to adjust your polygon. So just for the purposes of saving time right now, I'm going to delete all of these and import one that I've done previously. So I'll just delete all of these and I'm going to go to the import labels button. And within the workshop, we provide you under training labels, one called training cars paint markings. So this is one I did before. And you see I have car and handicap classes that it was previously defining. And if we click, we can just leave these on the default. We just hit import data. You see now it's imported in with our car and handicap. And if I zoom out, I have my training area. It's of that kind of similar parking lot area that I was defining. And all my cars and handicap spots are labeled.
So, just a quick clarification on the training area. You could go through and label all the vehicles in the entire image if that's what you wanted to do because it gave you better results. But if you feel that you don't need to, you can select the smaller area, and that's the purpose of the training area, right?
That's right. Yeah. It could be tedious to do the entire image. So.
Yeah.
So once you're happy with the training area, and at any point, I recommend you can always export your labels during the process if you want to save them or don't want to lose them. You can always export them by using the export labels function and export them as a 3DL file, which you can re-import again like I just did. But that's always a good tip if you're working through a lot of them, you want to make sure you don't lose something, export them frequently. So we can run training now simply by clicking the run training button.
Oh, no,
Yep.
you gotta leave me more space in order to.
Gotcha.
I think there might be enough, but let's just leave some silence before we jump in.
Okay. All right. So now we can run training on this image or on these labels. So what we do here, click the run training button. And this little window will pop up. This number of iterations is how many times the algorithm's going to look at some of these data sets and start learning from the data. I recommend images are pretty quick to run training on compared to the LiDAR classification. So I recommend at least starting with 1,000 if you can afford to wait longer or you have better GPUs, you might want to even do more iterations. But definitely start with a high number. And we got to pick a folder here. So you can select my results. And then we just click submit. So we'll let this start up here. So a few things to keep in mind. If you're running for this for the very first time on your computer may have to download some additional ML resources. And it'll do that automatically. You'll see an indication in this progress menu of that progress bar that's happening. But once it starts here, just like with the LiDAR classification, you're going to get a tensor board window that pops up showing you the accuracy of all the classes that were found. And just like before, you sometimes got to click this resize button once it gets some data here. Just give it a second. Hit refresh too. There we go. So we can click this third button and you see the graphs are now scaling to their respective values. So we're only done about 80 iterations and we're at about 80% accurate here. So we'll just let this run. Okay, Scott, so we are now finished the training. You may come back to your computer. If you walked away, you may come back to your computer with a message like this, saying that the TensorBoard server is maybe down or inaccessible. That is simply because the TensorBoard can't show any data because the process is finished. So this is quite normal. If you see this, you can just close this. It does indicate a log directory. So if you do want to view this TensorBoard stats on your model, you can always open, I'll just quickly show you where that is. You can open the solved engine function, search for the word model in here, and open the view model stats function and point this directory of the training logs to this same folder here and hit execute and confirm your workflow, and the TensorBoard will pop right back up with the same graphs that it had when it was finished. I'm going to go to Arial, my results, select that same directory, select model, execute, execute. Just give this a second for it to spin up. And there we go.
And there are the results from your training.
That's right.
Okay, great.
Okay.
Here are some key points to keep in mind. First of all, you need to have the right amount of good representative data. This is a little bit of a Goldilocks statement because right will depend upon the data you have and the object you're trying to identify. But basically, if you have too small a number of example objects relative to the overall image, or if you have objects that are too small in size relative to the overall image, you're going to get poor results. Likewise, you can get poor results if you don't identify all of the objects in the image. And this is because the objects you're trying to identify, if you don't label them, they get included in the so-called bad data that the model is looking at to recognize what is not the object. This is where the training area feature really comes in. You can reduce the size of the area that you tell the model to look at when it's training. This saves time and can also be used to improve your results. Finally, when you're picking your object, when you're selecting and labeling the example object, include a little bit of extra image around that object, as this can give the model some context for that object and it will often improve your results.